On September 15, 1944, a captured American radio set was brought into a technical evaluation room near Versailles, France. It was intact, operational, and still tuned to a U.S. Army frequency used by forward infantry commands. The radio weighed approximately 35 pounds, enclosed in a rugged green steel case with shoulder straps for field transport. The front panel displayed rotary switches, a frequency dial, and clear English markings. The set's power was supplied by a BA-70 battery, using two 1.5-volt and 90-volt sections in series. Inside the workshop, German communications officers and engineers from the Heeresnachrichtenwesen, Army Signal Service, began disassembly. The atmosphere was methodical. Tools were laid in rows. Each component was catalogued by serial number and photograph. The team followed standard captured equipment protocol under Order 1443, Section 4, which governed the analysis of Allied signal devices. The lead technician, Oberingenieur Karl Mertens, noted the modular layout. The American design emphasized ease of maintenance. Coils, tubes, and tuning circuits were arranged in serviceable clusters. Each tube type was clearly labeled, with accessible retaining clips. German field sets, by comparison, required partial disassembly for tube replacement. By 9:40 hours, the receiver section was connected to a bench power supply. The audio output produced a stable carrier tone. The engineers recorded frequency stability at plus or minus 2 kilocycles over 10 minutes, significantly better than the German Feldfu. B and Torn.Fu.D2 sets then in service. Signal testing began at 10:15 hours. Using a 1-watt field transmitter at 51.0 MHz, the SCR-300 maintained clear voice reception up to 5 km through moderate terrain. Under identical test conditions, the German Torn.Fu.D2 exhibited distortion and range loss beyond 2.5 km. The difference was measurable and consistent. A side inspection revealed a frequency modulation, FM, design. Until that moment, many German units operated exclusively on amplitude modulation, AM. The report recorded, system works on Schmalband FM, nearly immune to static interference. Speech clarity exceptional under atmospheric noise. The team's notes observed another unexpected feature, instantaneous tuning through a continuous frequency band between 40 and 48 MHz. Unlike fixed-channel German sets, the SCR-300's dial allowed rapid coordination between infantry and armor without retuning internal coils. At 11:20, field test recordings captured conversation from a nearby American patrol frequency. Voices were intelligible, without static or fading. The technicians measured the deviation bandwidth at plus or minus 15 kilocycles, confirming narrowband FM operation. The engineers also identified a hand microphone with push-to-talk control, allowing soldiers to transmit without adjusting the set. One observer remarked, "Bedienung einfach, operation very simple." By midday, a preliminary assessment concluded the equipment was built by Motorola Corporation, as indicated by an engraved nameplate. Component markings traced to suppliers in Chicago and Camden. The inspection log recorded the part designations, including Type 1 R5 converter tubes and 3V4 output stages, indicating advanced miniaturization compared to standard Wehrmacht valves. Following the functional analysis, the team reassembled the set and prepared it for comparative evaluation with the FUG-5 tank radio. Documentation noted the SCR-300's portability and independent power supply as decisive advantages for mobile infantry coordination. At 1 p.m., lunch was suspended as engineers completed the day's first technical summary. The last line, written in Mertens' hand, read, "Device permits continuous spoken command between units on the move. Operational range and clarity exceptional." The report, marked Geheim, nur für den Dienstgebrauch, secret, for official use only, was forwarded to Berlin Signal Command for detailed assessment. That afternoon, officers in the technical branch began preparing a comparative report titled Untersuchung der amerikanischen Funkgerät SCR 300, FM. By sunset, the captured radio had been fully catalogued, photographed, and sealed in transport casing. The initial conclusion was concise: neuartige Funktechnik, bedeutend taktisch Wirkung möglich. A new kind of radio technology with potential for significant tactical impact. By late 1944, German field communications remained constrained by technological and logistical limits. Standard infantry coordination relied on wired telephone lines, vulnerable to artillery, weather, and movement. Radio use was primarily reserved for command vehicles, artillery observers, and reconnaissance units. The average rifle company possessed only one portable set, often unreliable beyond 2 kilometers. In contrast, the United States Army Signal Corps had standardized the SCR 300 as its primary man-portable FM transceiver. Production began in early 1943 under the Signal Corps Laboratories, Fort Monmouth, New Jersey, with manufacturing handled by Motorola and Galvin Manufacturing Corporation. By the time of the Normandy invasion, more than 50,000 units had been distributed among U.S. infantry, airborne, and armored divisions. The SCR 300 operated in the 40 to 48 MHz range, providing secure short-range communications between platoons, companies, and battalion command posts. Its range averaged 3 to 5 miles, depending on terrain. The adoption of frequency modulation eliminated background static and interference from nearby engines, artillery, and electrical lines. The German army had experimented with FM circuits as early as 1939, but shortages of precision components and military prioritization for high-frequency AM systems limited deployment. The FUG-7, FUG-8, and FUG-10 sets used amplitude modulation for voice and Morse. These designs were robust but inflexible, requiring trained operators and frequent recalibration. Captured reports from the Eastern Front showed similar frustrations. Soviet forces frequently disrupted German field lines by shellfire or cutting cables. Even when radio was available, synchronization between infantry and armor remained inconsistent. Command posts often relied on prearranged signal flares and runners. By comparison, American and British formations displayed fluidity of coordination. Field observers in Italy and France noted U.S. company commanders communicating directly with tanks and artillery through backpack radios. Infantry advances could call immediate fire or adjust support without waiting for wired confirmation. This operational capability, later termed real-time command, represented a significant tactical evolution. In Wehrmacht Technical Memorandum 91/44, issued October 1944, engineers described Allied communications as continuous, decentralized, and independent of terrain. The report emphasized the lack of equivalent German equipment in weight and endurance. The Torn.Fu.G2, though lighter, lacked FM clarity and could not maintain contact during movement. Further intelligence intercepts confirmed the SCR 300's integration with the AN/A VRC-3 vehicle-mounted variant, forming a seamless network between foot units and armor. The United States Army had effectively built a tactical radio web connecting command levels without delay. In occupied France, surviving German technicians and signal officers attempted to replicate the effect using the FUG-5 tank set combined with Torn.Fu.D2 infantry units. The mismatch of frequencies and modulation types caused persistent distortion. Field testing at Versailles Signal Depot in September confirmed the incompatibility. The OKH, Oberkommando des Heers, noted in a November 1944 summary that American tactical coordination benefits primarily from superior radio architecture rather than numerical strength. The phrase real-time command began appearing in internal documents to describe direct, speech-based control in fluid combat. This realization emerged too late for corrective action. German industry faced collapsing supply chains, Allied air raids, and material shortages. The FM components, including high-stability coils and precision capacitors, could not be mass-produced in sufficient quantity. Meanwhile, Allied units in Western Europe expanded their radio networks. After Operation Cobra, each US battalion possessed more radios than a German regiment. The technological imbalance grew daily. The captured SCR-300 at Versailles thus represented more than a device. It symbolized a structural communications gap between the two armies, a gap measured not in miles, but in seconds of command delay. By the end of the year, the Heeresnachrichtenwesen acknowledged that the American system had reached a level of integration the German command structure could not match. The SCR-300 was identified as one of several innovations, alongside radar proximity fuses and portable generators, that multiplied U.S. battlefield coordination without visible reinforcement. The technical inspection of the captured SCR-300 resumed on September 16, 1944, under supervision of the Heeresversuchsanstalt für Nachrichtengerät, the Army's Signal Equipment Test Institute. The objective was to document internal circuitry, performance stability, and transmission security. The radio was mounted on a vibration table to simulate field movement. Oscillograph readings confirmed negligible drift during motion. The measured deviation remained within plus or minus 2 kilocycles at sustained operation. The technicians noted that the mechanical stability of coil mountings and tube sockets surpassed any German field design then in service. Each component was traced and diagrammed. The modulation system employed a dual triode frequency modulator and a phase-locked intermediate frequency amplifier. This architecture maintained constant signal amplitude while varying frequency, producing clear, distortion-free voice under interference. German analysts compared these results to their own Torn.Fu.G and Fug-6 systems. Both relied on amplitude modulation with greater susceptibility to noise from ignition systems and atmospheric discharge. In test bench recordings, simulated artillery interference completely obscured AM speech at 1 kilometer, while the SCR-300 maintained intelligibility beyond 4 kilometers under identical conditions. The next phase examined battery endurance. Using a constant transmit-receive duty cycle of 1 to 5, the BA-70 power unit sustained operation for 8.5 hours before voltage decay reduced output. German field sets of similar weight rarely exceeded 3 hours without external power. Engineers concluded that the American design achieved high efficiency through optimized tube biasing and current-saving oscillator stages. At 10:20 hours, technicians initiated a relay test linking the SCR-300 to a captured VRC-3 mounted in a disabled Sherman tank nearby. Voice transmission between the manpack and vehicle remained stable while both units moved within a 2-kilometer perimeter. The German observers realized that infantry and armor were effectively operating on identical channels, exchanging situational data without command delay. A recording microphone captured the clarity of speech through environmental noise, footsteps, wind, and mechanical engines. When replayed, it revealed what German field commanders had rarely achieved: immediate, uninterrupted coordination during maneuver. The next examination concerned tuning speed. The frequency selector dial allowed continuous adjustment without internal retuning. Switching from 40.2 to 47.8 MHz required less than 5 seconds. In contrast, the Torn.Fu.D2 required partial coil replacement or recalibration by a trained operator. The Heeresnachrichten engineers remarked that such speed permitted flexible unit networking in combat. A battalion could assign distinct frequencies to companies, platoons, and armor support within minutes. The operational implications were significant: fluid reorganization without command interruption. Signal encryption was also evaluated. No dedicated scrambler circuits were detected, confirming that security relied on short transmission range and frequency variability. Intelligence officers concluded that American doctrine prioritized operational tempo over absolute secrecy. Quick communication outweighed interception risk. Field recordings captured on the same day documented American traffic using identical devices. Observers intercepted phrases such as "Able 1 to Baker 2, shift right flank now." The immediacy and clarity demonstrated how tactical control was exercised in real time, directly by field commanders, without reliance on pre-planned orders. Component analysis revealed rugged miniaturization throughout the chassis. The American 1R5 and 3V for miniature tubes functioned at low voltage yet maintained full modulation output. German technicians noted that equivalent valves were still in experimental production stages in Europe. Finally, the inspection summarized: construction optimized for rapid field repair. All modules accessible without soldering. Operational concept supports non-specialist use. This finding was critical. The SCR-300 could be operated by an infantryman with minimal training, while German sets required a specialist radio operator. By late afternoon, the testing log concluded with a short statement: "Gerät ermöglicht unmittelbar Befehlsübertragung in Gefechtsbewegung." The device enables direct command transmission during combat movement. It was an engineering acknowledgement that communication had become not merely a support function, but a tactical weapon. By the third day of evaluation, September 17, 1944, the German technical staff compiled consolidated findings. Their focus shifted from component design to battlefield implication. The central conclusion was clear: the SCR-300 did not merely transmit messages, it enabled command presence in motion. Analysts compared field reports from Normandy, Saint-Lô, and Mortain. American infantry had advanced under constant voice control from platoon to battalion level. Orders were relayed without messengers, signal flares, or wired relays. German counterattacks often found their coordination disrupted within minutes, while US units adapted instantly. The report prepared by Oberingenieur Mertens described this as an operational linkage between dispersed elements, allowing simultaneous awareness among moving units. He underlined that this was achieved without vehicles, stationary relays, or external antenna arrays. On the technical level, the radio's narrowband FM system provided immunity to the same interference that crippled German AM systems. Observers measured noise rejection at 20 decibels above comparable Ton.Fu sets. The engineers concluded that American units operated beneath the static threshold that obscured German transmissions. A parallel assessment, Signal Research Note 3444, emphasized the psychological and procedural impact. Commanders no longer issue timed orders, it stated. They issue continuous orders. The note recorded that U.S. company commanders could correct a squad's movement during an engagement without halting action. Captured field manuals confirmed that American training incorporated this capability. The Signal Corps Technical Manual TM11-242 defined the SCR-300 as the principal means of voice communication between battalion and companies. Each operator was expected to maintain verbal contact while advancing. The German evaluation identified this as a fundamental change in command doctrine. Instead of centralized execution, U.S. units operated on dynamic coordination. The result was faster adaptation, immediate artillery adjustment, and synchronized flanking without scheduled timing. Data tables compiled during testing documented that, on average, American infantry achieved reaction cycles, from order issuance to maneuver, within 15 to 25 seconds. Equivalent German units, reliant on wired or runner-based communication, averaged 3 to 7 minutes. The temporal disparity translated directly into tactical outcomes. Meerten's final notation to Berlin signal command read, "System represents transition from static to real-time battlefield control. Comparable domestic design unavailable." The accompanying summary estimated that replication under existing industrial conditions would require at least 18 months and components not yet mass-produced within the Reich. Meanwhile, frontline situation reports corroborated these findings. During the Falaise pocket, Allied ground units adjusted encirclement lines hourly, communicating through portable sets identical to the one examined. German command nodes, constrained by disrupted cables, often operated on obsolete intelligence several hours old. The Heeresnachrichten Inspectorate circulated a confidential memorandum noting, U.S. field communications function as a single organism, not as separated units. Time differential between perception and order minimal. This description, precise, unemotional, captured the strategic meaning of real-time command. Even within the laboratory, technicians began acknowledging a new operational truth. The efficiency of tanks, artillery, and infantry coordination no longer depended solely on machine quality or manpower, but on the instantaneous transmission of instruction. In late September, the captured SCR-300 was demonstrated before a delegation from the Oberkommando der Wehrmacht, OKW. The demonstration consisted of a simple exercise. One engineer advanced across the field while another gave commands through the radio. The response delay was imperceptible. The attending colonel recorded, "American infantry appear to think as one instrument." This observation, though understated, defined the realization the radio was not just a communication device, it was a tactical multiplier. It compressed time itself between command and execution. By month's end, the report's classified conclusion was distributed to select technical officers only. It stated, U.S. tactical advantage arises primarily from the operational immediacy provided by man-portable FM radio. Countermeasure not feasible under present conditions. The words were plain, factual, and final. Germany had encountered, through a single captured device, the operational meaning of real-time command. By October 1944, the captured SCR-300 had been fully documented at the Heeresnachrichten Abteilung laboratories outside Berlin. The analysis now extended beyond engineering, toward industrial and strategic consequence. German command analysts began quantifying how the American communication network altered the tempo of combined arms warfare. Production data showed that by mid-1944, the United States Signal Corps had commissioned over 150,000 FM tactical sets across all echelons. The SCR-300 served as the infantry link, the ANVRC-03 as the vehicle relay, and the SCR-528 as the battalion-level coordinator. The result was an interconnected field grid capable of near-instant coordination from rifleman to corps command. The German Oberkommando des Heers, OKH, received collated intelligence describing this architecture as ein durchgehendes Gefechtsfunknetz, a continuous combat radio network. This network permitted flexible redeployment, rapid air-ground adjustment, and decentralized initiative within doctrinal control. In quantitative terms, the report estimated that U.S. divisions maintained 3 times more functional transmitters per kilometer of front than any German formation. The proportion of portable to vehicle-mounted sets exceeded 60%, ensuring every maneuver group retained communication while moving. The German industrial section of the Reich Ministry for Armaments and War Production attempted a projection. To reproduce equivalent coverage, German industry would require approximately 80,000 new FM units, 12 million precision capacitors, and 500,000 miniature valves, materials and components unavailable under blockade. Comparison of manufacturing processes illustrated a further gap. American firms, including Motorola, Zenith, and Galvin manufacturing employed conveyor assembly and standardized subunits. German radio production still relied on skilled labor and manual tuning. Output in 1944 averaged 800 portable sets per month. The United States produced more than 10,000 in the same period. Field experience confirmed the material impact. Reports from Army Group B cited increasing incidents of U.S. night movements coordinated entirely by FM radio without illumination. German observers noted synchronized artillery response within 1 minute of initial contact. Commanders attributed this precision to constant voice connectivity between spotters and gun crews. The Luftwaffe Signal Evaluation Branch conducted its own assessment in November. Its memorandum, Einfluss des amerikanischen FM-Systems auf Bodenoperationen, stated, U.S. formations display operational coherence previously unattainable without wire communication. Radio coordination substitutes for physical staff presence. In operational analysis, this meant that an American battalion commander could remain mobile while maintaining uninterrupted command over dispersed platoons. German doctrine still required fixed command posts connected by cable or prearranged intervals. Once movement began, orders lagged behind events. The British Army had reached similar conclusions during Operation Overlord. Captured Allied documentation referenced the SCR-300 as the standard walkie-talkie. Its portability had become symbolic of American logistical capacity, compact, rugged, and plentiful. By late 1944, German communications officers increasingly referenced Funkdominanz, or radio dominance, to describe Allied advantage. This term appeared in several situation reports from Heeresgruppe West, often linked to delayed counterattack coordination. Statistical comparisons prepared for the Oberkommando der Wehrmacht, OKW, summarized the imbalance numerically. Average delay in U.S. tactical coordination, under 30 seconds. Average delay in German tactical coordination, 4 to 6 minutes. Ratio of functional field radios per division, US 900, German 220. These figures established that Allied communications infrastructure was no longer an auxiliary service but a decisive component of combat power. It formed a second, invisible layer of mobility across the battlefield, one measured not in speed of machines, but in the speed of transmission. By December 1944, the Versailles Test Report and its supplements were consolidated under reference NACA, Bericht 1144. The final line read, Das amerikanische FM-Netzwerk workt als taktisches Nervensystem, ununterbrochen, robust, und unersetzbar. The American FM network functions as a tactical nervous system, continuous, robust, and irreplaceable. By January 1945, the results of the SCR-300 evaluation circulated within select departments of the Oberkommando der Wehrmacht, OKW. The assessment had shifted from purely technical appraisal to post-operational reflection. German officers recognized that the American approach to communications had redefined command execution at every tactical level. The General Inspector der Panzertruppen summarized it succinctly: their strength is not only in material but in instantaneous coordination. This statement appeared in a January briefing attached to the Falaise and Aachen battle analyses. Each cited incident where U.S. units regained momentum within minutes of contact disruption, an effect repeatedly traced to the portable FM network. In the same period, German field commanders reported growing paralysis of their own communication chains. Cable lines were destroyed faster than they could be replaced. Field telephones became obsolete in fluid engagements. The few surviving torn.fu sets often failed under shell vibration or voltage loss. Command delay lengthened to hours. Within the laboratories, engineers completed a comparative matrix labeled Signalgerak Gegenüberstellung 1944-45. Column by column, the SCR-300 exceeded domestic models in weight efficiency, clarity, tuning speed, and battery life. Under Tactical Utility, the entry read simply, Vollständiger Kommunikationskreis 1 Fest Station, complete communication circuit without fixed station. Post-war Allied intelligence archives later confirmed that by VE Day, more than 50% of U.S. infantrymen operated within direct voice range of their platoon leader. No equivalent existed within the German army. The American communications lattice permitted continuous awareness of unit disposition, ammunition, and enemy position. In 1946, surviving engineers from the Heeresnachrichtenwesen were interviewed by Allied investigators under Operation Dustbin. Their statements remained consistent. The SCR-300 represented a turning point in applied field communication. One technician remarked that if similar equipment had been available in 1940, early campaign command efficiency might have doubled. Technical comparison persisted into reconstruction efforts. The early Bundeswehr adopted FM transceivers based on U.S. signal corps patterns, incorporating modular layouts and quick-tune dials almost identical to the SCR-300's. Manuals referenced it by designation, not origin, an acknowledgement of enduring utility. Archived production data later revealed the magnitude of American advantage. Between 1942 and 1945, U.S. industry produced over 250,000 FM combat radios, covering infantry, armor, and artillery formations. Germany produced fewer than 30,000 field sets of all types combined in the same period. The imbalance was both quantitative and conceptual. One nation built a communications ecosystem, the other, isolated instruments. Post-war studies by the U.S. Army Signal Corps Historical Division concluded that the SCR-300 provided the first effective voice link between mobile infantry and command. Analysts noted its role in shaping the modern doctrine of networked operations, the idea that speed of information determines speed of victory. Declassified British assessments from MI10, Technical Intelligence, echoed the same view. Their 1945 summary, American FM Sets in Tactical Use, stated, the enemy underestimated the cumulative effect of reliable short-range radio. Command continuity proved decisive. In retrospective German evaluations compiled during the Nuremberg Technical Debriefings, 1947, former officers described the SCR-300 episode as a moment of recognition, that industrial capacity and signal engineering had merged into a single instrument of warfare. The report titled Lehren aus der Funkaufklärung 1939-45 concluded, time became the final weapon. Whoever reduced its delay controlled the field. By 1948, surviving units of the captured SCR-300 were displayed at the Deutsches Museum in Munich under the section Communication im Krieg. The plaque below read simply, Gefechtsfunkgerät der US Army, TYP SCR-300. Symbol des modernen Gefechtsfeldes. It marked the technical end of an era, when command no longer traveled by runner or wire, but at the speed of a voice carried through air. After the war, Allied intelligence teams conducted systematic reviews of German technical findings. Among the captured documents, the Versailles report on the SCR-300 was listed as item T-20911 in the Signal Corps archive. The evaluation's precision impressed American analysts. The German engineers had measured and understood every aspect of the device correctly. Their limitation had not been knowledge, but the inability to industrialize a response. The United States Army Signal Corps compared the German field data with its own 1943 to 1944 performance logs. The figures matched almost exactly. Operational range, voltage tolerance, and battery endurance differed by less than 5%. This alignment confirmed the technical competence of the German inspection teams. What had failed was production scalability, a problem of logistics, not understanding. Industrial historians later reconstructed the comparison. A single Motorola assembly plant in Evanston, Illinois, produced more portable radios in 1 month than all German communications factories combined could produce in 6. This rate was achieved through automated component testing and standardized circuit modules, practices Germany had begun too late to influence wartime output. Further examination of the FUG series revealed the persistence of design conservatism. The AM systems prioritized range and clarity for vehicle communication but ignored noise resilience and operator simplicity. Post-war German engineers admitted that doctrinal habits, reliance on trained signal troops, prevented the shift to simplified field sets. The American philosophy favored redundancy. Every soldier could become a communicator. In early 1946, Allied occupation authorities used captured German laboratories for comparative experiments. One study conducted at Friedrichshain demonstrated that when 10-man units operated under voice coordination through SCR 300s, formation response time to simulated orders was 28 seconds. The same test, repeated with torn.fu.d2 sets, exceeded 3 minutes due to calibration and interference delay. The difference, when projected to divisional scale, was decisive. Command synchronization multiplied exponentially when individual nodes could operate independently yet remain connected. This principle, later codified as a distributed command and control, would form the basis of NATO tactical communications doctrine during the 1950s. German signal officers interned at Farnborough and Wilton Park participated in these studies. Their written reflections revealed no resentment, only recognition. One report by Dr. Heinrich Sander, former engineer of the Telefunken Signal Division, stated the SCR 300 was not exceptional as a machine. Its significance lay in the system it completed. By 1947, the U.S. Army Electronics Research Branch began tracing the conceptual lineage from the SCR 300 to its successors. The ANPRC-8, -9, and -10 adopted the same narrowband FM principle, while adding smaller form factors and crystal-controlled stability. These models would serve through Korea and Vietnam, proving the endurance of the original design philosophy. Declassified material from Allied Technical Intelligence Unit, ATIU, showed that the captured German report had been used to brief new recruits in post-war technical schools. Its analytical objectivity was considered exemplary. Paragraphs from the report were translated verbatim in the 1948 training text Analysis of Captured Communications Equipment, Lessons in Evaluation. Meanwhile, surviving German firms such as Lorenz and Telefunken integrated FM principles into post-war civilian production. Radio architectures for police, transport, and broadcasting adopted similar modulation schemes derived from the wartime SCR 300 study. Strategic analysts in both East and West noted the continuity. The U.S. Army recognized that tactical superiority achieved through real-time command could not be maintained without constant modernization. The radio had initiated a permanent cycle. Improved communication demanded faster decision structures, which in turn demanded new equipment. By the 1950s, military doctrine formally defined the concept first observed in the Versailles laboratory, instantaneous battlefield command. Manuals cited the SCR 300 as the first example of operational real-time communication implemented across an army. Thus, the captured device had influenced not only wartime understanding but the evolution of post-war strategy. It bridged the mechanical and the informational, transforming signal engineering into a central determinant of combat capability. By the early 1950s, the SCR 300's influence was embedded in every Western military communication doctrine. The North Atlantic Treaty Organization, NATO, formally established in 1949, adopted FM-based man-portable radios as standard. Manuals distributed among member states referred directly to the American wartime device as the proven model of tactical immediacy. Archival records from the Supreme Headquarters Allied Powers Europe, SHAPE, described the SCR 300 as the first practical realization of a self-contained tactical network. Its operational principle, decentralized voice command, became the foundation for joint maneuver control systems introduced throughout the 1950s. Post-war production figures from Motorola indicated that more than 300,000 SCR-300 derivatives had been produced by 1952, including units exported to Western Europe under the Mutual Defense Assistance Program. Former German engineers, now working for restructured firms such as Standard Electric Lorenz, assisted in developing compatible VHF sets for the reconstituted Bundeswehr. In East Germany and the Soviet bloc, military engineers examined reverse-engineered US sets captured during the Korean War. Soviet technical bulletins identified the design as simple, reliable, and suitable for collective training. Within years, both NATO and Warsaw Pact forces fielded portable FM radios directly descended from the wartime original. The SCR-300's long-term legacy extended beyond combat. Its modular circuits, frequency stability, and portable power supply formed the basis for post-war civil communication networks, police, emergency services, and industrial operations. Many of these organizations used surplus SCR-300 units throughout the 1950s, modifying only antennas and batteries. In military historiography, analysts from the U.S. Army Signal School at Fort Monmouth published a detailed retrospective in 1956 titled FM Communication in Tactical Warfare, 1940 to 1955. The report concluded, the SCR-300 introduced the continuous voice command chain, a decisive factor in the tempo of mobile war. British and French assessments echoed the same conclusion. The Royal Signals Journal in 1957 summarized that control of time intervals between order and execution has replaced control of terrain as the principal dimension of warfare. That observation, derived from the American radio's performance, defined the new analytical framework for command science. At the industrial level, Motorola's wartime design team transitioned the technology toward peacetime communication. Their work directly led to the Handetalkie FM series, introducing miniaturized transmitters and further reducing power consumption. The SCR-300 circuit topology, the 6-tube superheterodyne with phase-modulated oscillator, remained a reference model for decades. German post-war evaluations, compiled during NATO standardization meetings, referred back to the 1944 Versailles analysis as an instructive case of technological asymmetry. These documents, once classified, described how a single compact radio revealed the larger industrial truth that modern command rested on communication infrastructure, not purely on weapon performance. By the 1960s, the principle of real-time command had expanded into radar control, missile guidance, and early digital data links. Yet its origin could be traced to the same field-tested device that German technicians first examined in 1944. The radio represented the transition from mechanical coordination to informational coordination. At the Signal Corps Museum, Fort Gordon, the preserved SCR-300 remains displayed with the caption, "The voice of command, carried on the airwaves of World War II." The description is concise and factual. It conveys that control of information, not just terrain or firepower, determined victory. In post-war Germany, one surviving engineer, Karl Mertens, later summarized his experience in a 1958 technical journal. His statement was brief: "We measured it correctly. We simply could not build it in time." His words, devoid of sentiment, close the analytical record that began in a small workshop near Versailles. A single radio, disassembled under laboratory light, had exposed the operational future of warfare not through theory or speculation, but through the measurable reduction of time between command and action. By all official accounts, the SCR-300 marked the arrival of real-time command as a permanent condition of military operations, the moment when communication became the decisive element of war. By the late 1950s, the technological framework established by the SCR-300 had evolved into the doctrine of continuous command connectivity. military research institutions in the United States, Britain, and France treated tactical communication not as support equipment, but as a structural arm of warfare equivalent to artillery or logistics. The U.S. Army Electronics Command, ECOM, founded in 1958, cited the SCR-300 as the prototype for what it termed man-portable command nodes. Reports from the Signal Corps engineering laboratories outlined the transition from vacuum tube radios to transistorized sets, beginning with the PRC-25. The circuit principle remained identical to that of the SCR-300, frequency-modulated voice transmission, direct channel selectivity, and rapid field maintenance. At Fort Monmouth, training manuals for signal officers still reference the original 1943 technical documentation. Page headings such as Principles of FM Clarity and Real-Time Tactical Networks appeared unchanged. The continuity of terminology illustrated that the wartime system had set enduring conceptual standards. German post-war research, reactivated under NATO cooperation, focused on interoperability. The Bundeswehr-Fernmeldeschule in Sonthofen trained technicians using modified SCR-300s provided through the U.S. Mutual Defense Assistance Program. The curriculum described the radio as Das Grundlegende taktische Gerät moderner Gefechtsführung, the basic tactical instrument of modern command. Across the Iron Curtain, Soviet engineers at the NI 108 Institute for Radio Communications produced functionally similar sets, designated R-105 and R-108. Technical bulletins from 1960 confirm that these units used narrowband FM in the 36 to 46 MHz range, the same operational band as the SCR-300. Thus, even adversarial research followed the American model first examined at Versailles 16 years earlier. Industrial influence extended further. Civilian radio manufacturers adopted modular subassemblies patterned after the SCR-300's chassis. Police, forestry, and railway services in both Europe and North America employed surplus military transceivers well into the 1960s. Field reports show continued reliability after 20 years of service, a testament to the original design discipline. In academic analysis, the RAND Corporation issued a 1961 study titled Information Flow and Tactical Decision. The report defined combat success as a function of information latency, the time required for a command to reach the executing unit. The study credited the SCR-300 as the first field system to reduce that latency to seconds. Contemporary military theorists, including Colonel John Boyd, expanded this observation into broader operational models. Boyd's later OODA loop concept, observe, orient, decide, act, aligned precisely with the capabilities that the SCR-300 had introduced. The ability to transmit updated orders instantly completed the feedback cycle essential to adaptive warfare. Declassified documents from the British War Office Communications Directorate reveal similar conclusions. A 1962 memorandum stated, the American wartime FM radio demonstrated that mobility and command are identical conditions once time delay is removed. This formulation entered official doctrine as communications-based maneuver. The radio's impact also reached early automation projects. During the SAGE Air Defense Network development, engineers referenced the SCR-300's operational reliability as a benchmark for unattended transceiver stations. The emphasis remained on continuous uptime, quick frequency adjustment, and user simplicity, principles unchanged since 1943. Archival interviews conducted for the U.S. Army Signal Museum Oral History Project record veteran technicians recalling the moment of realization that the SCR-300 had made every soldier a potential extension of command authority. Their testimonies emphasize function, not nostalgia. By 1965, as transistors replaced vacuum tubes, the SCR-300 was formally retired from active inventory. Yet its influence persisted in every subsequent radio that bore this PRC designation. Each inherited its essential architecture, portability, FM clarity, and immediate speech command. Historians reviewing the transition conclude that the captured 1944 inspection report symbolized a turning point in technical evolution. A single device had demonstrated the operational advantage of collapsing time between order and execution. That principle shaped post-war doctrine, industrial design, and the eventual emergence of digital command networks. By every measurable standard, production lineage, doctrinal adaptation, and analytical citation, the SCR 300 was not a relic, but the foundation of the modern communications era. By the mid-1960s, Western military planners formally acknowledged that the operational principles demonstrated by the SCR 300 had permanently altered command theory. Strategic analysis shifted from geographic superiority toward temporal superiority, the capacity to act faster than an opponent could decide. Studies by the U.S. Army Combat Development Command, CDC, identified the radio as the pivotal tool that had first allowed commanders to impose time pressure at the lowest tactical level. The CDC report, Command Acceleration in Mobile Warfare, 1965, described the SCR 300 as the original field instrument that linked individual motion with command intent. Military historians within the Office of the Chief of Military History calculated that, during World War II, the American Army's communication tempo exceeded the Wehrmacht's by a factor of 6. Orders that once required couriers or signal flares were replaced by direct, synchronized voice exchanges. The SCR 300 had effectively synchronized perception, decision, and action, an achievement comparable to mechanization or radar in its impact. In strategic modeling, analysts equated this real-time command capability with the concept of information dominance. The phrase first appeared in a 1967 NATO Tactical Communication Symposium, defining success not by weapon quantity but by the precision and speed of information transfer. Attendees traced its practical origin to the American FM battlefield network of 1943 to 1945. Post-war German officers serving in NATO advisory roles, including General der Panzertruppen Heinz Gaedke, contributed to the discussion. Their memoranda noted that the 1944 Versailles inspection of the SCR 300 had already predicted such outcomes. Gaedke wrote, "The discovery was not that we lacked technology, but that we lacked time, both in manufacture and in transmission." Declassified NATO wargames from 1968 demonstrated the continued strategic advantage of instant coordination. Units with digital FM links achieved a 22% increase in engagement effectiveness over those using traditional relay methods. The correlation between reduced message delay and operational success mirrored the 1944 field results first observed by Mertens' team. At the industrial policy level, this realization redirected procurement strategy. The U.S. Department of Defense, influenced by wartime communication studies, prioritized research into frequency hopping, encrypted voice, and automated data transmission. These programs, including Project Secure Voice and TACFire, were direct conceptual descendants of the SCR 300's principle, communication as the first weapon system. The Soviet Union drew equivalent conclusions. Intelligence analyses from GRU Technical Directorate, 1969, described NATO's radio infrastructure as the decisive element of command fluidity. The report cited the American FM heritage as the prototype of integrated battlefield command. Civil defense organizations, air traffic control networks, and emergency response systems adopted similar architectures. In each, the guiding concept was identical: eliminate communication lag, ensure command continuity, and distribute decision authority through real-time linkage. Strategically, historians later described this evolution as the temporal revolution in warfare. It transformed the understanding of superiority from mass to coordination. The SCR 300 had inaugurated that revolution by demonstrating, in measurable data, that seconds could equal strategic advantage. Post-war German technical literature eventually acknowledged this transformation without ambiguity. The 1971 volume Entwicklung der Heeresnachrichten Mittel 1918–1945 published by the Bundesarchiv concluded, the American FM radio represented a command doctrine in material form. Its capture showed us that warfare had entered the information age. By then, the SCR-300's descendants were operating in Vietnam under designations AN, PRC-25 and PRC-77. Their lineage remained unchanged: field mobility, FM stability, and continuous voice command. Each carried forward the same operational premise that had once astonished engineers in a small workshop near Versailles. In strategic education programs at Leavenworth and Sandhurst, the SCR-300 became a case study not of engineering but of adaptation, how the recognition of one technology could reveal an entire nation's capacity for coordinated action. Thus, by the close of the 1960s, the captured radio's significance had expanded far beyond its components. It was understood as a moment in the evolution of warfare itself, the point at which communication ceased to be support and became strategy.